Let me start by showing you where school fits in your life. If I were to ask the question, how long do people live? What answer do you think we get? There's no exact number, of course, but 80 years is a good number to work with. So let me start off by drawing a line and marking it off in tens out to 80 years. If this is your lifeline, where's your first birthday? Right up here in front. Next, let's show the time you spent in school. You start school when you're about 6 years old, and you finish when you're about 18. So this area shows the time you'll spend in school. After high school, some people go to college, some go to work, some go backpacking in Europe. It's different for everyone. So we'll leave kind of a question mark here. But most everyone will begin work at some point in their life. So we'll show that. How long you'll be working? The traditional age for retirement is 65. So this bar shows the years you will spend working. And to give you a little more perspective on this, let's put marriage on this line as well. And here too, there's no set answer for when people get married. Some people never get married. But it's common for those to get married in their 20s or 30s. So we'll show that here. Okay, on this line, where are you now? Right here. Let's take a closer look at just the school years. The 12-year education program is split into what we call primary and secondary education. There are traditional reasons for this, but you're probably more familiar with the labels elementary school, middle school, and high school. It's useful to consider the kinds of skills you get from primary and secondary levels. Primary education gives you just the minimum survival skills, what used to be called reading, writing, and arithmetic. Secondary education builds on this and tries to give you some more sophisticated skills. It won't make you an expert at anything, but at least it gives you a look at what's out there and helps you decide what you'd like or what you're good at. As I mentioned earlier, the math curriculum is a 12-year plan. So let's look at how this is laid out over a 12-year period. What's the first thing you learned in math? Numbers and counting. I'm pretty sure everyone knows their numbers and counting, so far school's done a good job. After that came addition and subtraction, followed by multiplication and division, and finally fractions and decimals. Before I go too far with this, let me make a group out of these things. The next things you learned in math were probably things such as ratios, percentage, and proportion. They also teach you things like charts and tables and graphs, and maybe even some statistics and probability. I'm going to call this the world of weights and measures. This is the math at the heart of all business and trade, and dates back to the earliest traders and merchants. These are the kind of things that you would have used if you were, say, a merchant in ancient Babylon, and you were trading things like sheep or rice or silk. As long as we're here, I'd like to mention something which is closely related. I call this business math, and is used in all banking and business. This includes things such as accounting, interest and loans, and things such as amortization and depreciation. This is the math used by people who do any kind of buying or selling, and have to figure out taxes and payroll. Up to this point, the things we've looked at are all things you've already been studying. You've probably heard that soon you'll be taking things like algebra and geometry, but you may not know exactly what those are. This is part of the 12-year plan that's still a bit mysterious. So let's look at it. Algebra is a special type of math and sort of stands all by itself. I like to call this one into the unknown. Up to now, when you performed a calculation, you basically had all the numbers you needed to work with. Algebra is the math where you don't have all the numbers. Something is missing and you need to use math to find it. How do you know when you've got an algebra problem in your hands? Pretty simple. If you ever had a math problem that contains the question, what if? You're working with algebra. There are a lot of problems like this. For instance, if you were mixing a recipe and you needed to adjust the quantities. Let's say your recipe calls for 5 pounds of flour, but you only have 4. How would you adjust the other ingredients and keep all the proportions the same? You've just asked a math question with the phrase, what if? Welcome to algebra. By the way, algebra represents a kind of mental hurdle, thinking in the abstract. This is a hurdle we're going to try and get as many people to jump over as possible. The reason is a whole world of possibility opens up on the other side. There are a lot of problems where we need math to help us find something that is missing, and algebra is the stuff that helps us do exactly that. You've probably heard the terms geometry and trigonometry, but didn't know exactly what they were all about. This is the math you use anytime you reach out and touch something in the physical world and try to do something with it. If you handle bricks or beams, or cut carpet or cloth, put up walls, lay pipe, dig foundations, this is the math you use. This is the math that allows you to make physical things. So I'm going to call this the foundation for the physical world. Want to know the difference between geometry and trigonometry? Geometry is the math of things that take up area, that is, things that are flat. Carpet, walls, floors, roads, and lands are some examples. Trigonometry is the math of things that take up volume or space. Water or fuel tanks are a good example. Any kind of building or structure. By the way, this math only forms the foundation for the physical world. There's a lot more needed if you want to make complex things like buildings and bridges and airplanes. But this is where it all starts. Well, if you've come this far, you've covered a tremendous amount of ground in math. But believe it or not, there is more. There is lots more. Above this level is the math that is used for science and engineering. And at this point, the sky's the limit. In fact, the sky is exactly the limit. This is the math that is used to put men into space. You may have heard the term calculus, but you didn't know what it was all about. Calculus is the math of problems where things are moving around and changing on you. A very good example of a problem like this is landing a spaceship on the moon. Landing on the moon involves handling a lot of things at once. First, you have to deal with gravity. The moon has gravity just like the Earth. The gravity on the moon isn't as strong as on Earth, but it works exactly the same way. Gravity is a very interesting thing because its effect is very strong when you're close, but gets weaker as you get further away. Imagine, for example, you weigh 100 pounds standing on the ground. And out in space, you weigh 0. Well, somewhere in between, you weigh 50 pounds, and you get closer and you weigh 75 pounds, until you get all the way back down to the surface where you weigh 100 pounds. When the spaceship is landing, it has to fire its rocket so it doesn't fall and crash onto the surface. But because the effect of gravity gets stronger as you get closer, you have to increase the thrust on the rockets. But there's another problem. Firing the rockets means burning fuel. And as you burn fuel, you get lighter, so you need less thrust. The final problem is that you only have so much fuel. If you use it up too soon, you'll fall and crash anyway. So, here's the whole problem. Number 1, you have to deal with the effects of gravity, which is not constant. 2, you have to provide the right thrust to come down and make a soft landing. And 3, you have to control that thrust because the spaceship is getting lighter and use up fuel. And you have to do the whole thing with split-second timing so you don't run out of fuel before you touch down. How do you solve a problem like this? Welcome to the world of calculus. Calculus is an amazing type of math that can handle a whole range of problems. Everything from calculating stress forces on the wings of airplanes, to making computer models of the weather, to predicting how bacteria grow and spread. It's used to build airplanes and satellites and power plants and computers, communication systems, and even, yes, the internet. At this point, we've looked at a lot of different types of math. But it's important to know who uses this and what it's good for. I'd like to see if I can show that by rearranging this a little bit. Basically, I'll just push everything over to the side except for algebra, which I'll move down a bit. The reason is that the principles of algebra, the idea of finding an unknown, can be found everywhere. And it's built into a lot of things, even if we don't see it. So okay, first comes number manipulation. Who uses this? Well, everybody uses this. This is all the basic arithmetic used for everything from adding a grocery bill to doing taxes and figuring up a tip at a restaurant. Above that is the world of weights and measures, which also includes business math. This is the math used by anyone in business or trade, banking, sales, insurance, real estate, a stockbroker, a travel agent, even small shops such as a hair salon or a nail salon. If you see yourself in any of these professions, then this is the math you need. By the way, if there's any math snobs out there or think that business math is too simple or unimportant, just let me point out the next time you drive through a nice neighborhood and see all those rich houses with swimming pools, some of those people are just businessmen, and this is the math they used to get where they are today. Next comes the foundation for the physical world. This is used by such people as carpenters, machinists, general contractors. This is the math used by anyone who lays carpet or tile, installs pipes, cuts material, puts up walls or beams, handles bricks, Foundations. This is the math you use anytime you roll up your sleeves and grab hold of something in the physical world and make or build things. Above that comes the world of science and engineering. These are the people who are making and inventing new things, designing cars, airplanes, making things like computers and communication systems, inventing new compounds and medicines. These are the guys that built the internet. These are the guys that fly into space. So, if you can see yourself doing any of these things in the future, you can see which kind of math you need. If you can master those math skills and techniques, you can have those jobs and careers.